let's look at an example. This first example says we have a simple random sample of 50 adults, and each person's red blood cell count is measured, and the sample mean is 5.23, and the population standard deviation for red blood cell counts is 0.54. They want us to use a 0.01 significance level to test the claim that the sample is from a population with a mean less than 5.4, which is a value often used for the upper limit of the range of normal values. What do the results suggest about the group? So in this problem, they want us to do a hypothesis test on their claim that the mean is less than 5.4. So our claim is that the mean is less than 5.4. Notice we're going to use the letter mu for the mean, and we have a less than symbol, which means that our claim must be H1 because there is no equal to. So we will put our claim as our H1. This means that automatically our null hypothesis is the complement or opposite of that, which means that the null hypothesis will have the opposite, which is greater than or equal to. Now the question is, what kind of test are we going to do? Well, if you go back to the original problem, we notice that they said specifically that the population standard deviation for the red blood cell counts was 0.54. This means that they are flat out telling us that we have sigma. So that means that we are going to be doing a z-test because we have sigma. So we can go into our calculator and pull up z-test. So notice we don't have a set of data in this one. We just have a bunch of information they gave us in the original problem. So we'll pull up the z-test and we'll make sure that we choose the option stats because we do not have a data set. Well, the first piece of information they want us to input is mu naught, which is the mean from our claim. Well, they claimed that the mean was less than 5.4, so we're going to input 5.4 as our mu zero or mu naught. Next, they want to know what is sigma, our population standard deviation. Well, according to the problem, that was 0.54, so we can enter that. Also, in the original problem, they told us that the sample mean was 5.23 and that the size of our sample was 50. The last piece of information they want us to give is going to determine whether or not they're going to do a left-tailed, right-tailed, or two-tailed test. Well, this is going to be the symbol from the alternative hypothesis, which was our claim, which had a less than symbol, so we will choose the less than symbol from all the options. Then at the very end, we'll arrow down to calculate and press enter. Then our calculator comes out with the following result of the z-test. The two parts that we're going to care about are the z-value and the p-value. Now we're only going to use the z-value if we are actually going to do the rejections regions approach. In this one, we want to do the p-values approach, so we're only going to use the p-value. And the p-value, according to the calculator, is 0.013. So now we have to put that in perspective. We always ask the same question. Is p less than or equal to alpha? Well, according to our calculator, our p was 0.013. According to the problem, our alpha, our level of significance that was given in the original problem, Again, alpha is your level of significance. It's always given in your problem. Your level of significance given in this problem was 0.01. And this is just a yes or a no question. Is P less than or equal to alpha? Is 0.013 less than 0.01? And the answer is no. Because if you look at that third decimal place, which for the P is 3, and we don't see one right here after the 1, in the alpha, well, then it's a hidden 0 as a placeholder. Well, then that means the 3 is actually bigger than the 0, which means no. P is not less than or equal to alpha. So we're going to go ahead and say no. Remember, if the answer is no, that means we fail to reject H0. Remember, failing to reject H0 does not mean that we're accepting. So as a reminder, we had our H0 and our H1. Our H1 was that our mean was less than 5.4. That was our claim. And that means our null hypothesis was mu was greater than or equal to 5.4. So if we fail to reject our H0, so we'll fail to reject. That's actually not what we want. We actually care about what the claim is. Well, if we fail to reject H0, it means we're actually going to fail to accept. Again, we're going to do the opposite. We're going to fail to accept the alternative hypothesis, which is where our claim is, what we actually care about. Remember, because we are failing to accept, that means that there's going to be insufficient evidence. Remember, failing to do something means that we're not able to do it. And in this case, because we're looking at the alternative, we're failing to accept. So we'll leave out the rejecting part. We're failing to accept the claim that the mean is less than 5.4. Now